Alright, hi everyone. We're going to be looking over current, voltage, and drift velocity equations and problems. Here's some of the vocabulary and the equations for each one. I think the current equation and voltage equation are kind of self-explanatory. They're not very difficult, so I'm not going to go through those. I will go through the drift velocity equation because it does have a little bit more to it. So the drift velocity equation is current divided by the free electron density times the cross-sectional area times the charge. Now, all this was found on the remediation website, as were all of the problems after this. So, if you want to go through more, just go to the remediation website. So originally, the drift velocity equation was the current was a second current equation, which is the free electron density n times a times the drift velocity times the charge, but we rewrote it so that it gave us the drift velocity. I recommend that you guys put it on pause right now if you don't have these equations with you, if you don't have your binder or you just can't find the equations. I recommend you put it on pause and you write these down because you're going to be needing them for the problems that are coming up. All right. So the first problem, is a potential difference of 12 volts is causing electrons to flow through a wire so that 1.4 times 10 to the 20th electrons passes through a point in the wire in 1 minute. Those are the two parts right there to the question. We've written down the givens for the question just to make it a little bit easier and quicker, I guess, and some prior knowledge that you might need, that you will need in order to solve this that you might not have had. So the charge of 1 electron. Go ahead and try and figure this out now. Put it on pause. Do the equation. Figure it out, and we'll go through it real quick when you're done. When you get back. All right. So the first part, the goal is to find the charge, and the necessary equation is the charge equation, of course. So the givens are right there that you're gonna need. So you really just have to plug and chug at this point. This one isn't very complicated. It's just pretty self-explanatory, I guess. So there you go. Q equals 1.4 times 10 to the 20th electrons times the charge of 1 electron in order to get the charge of everything, which is 22.4 coulombs. All right. Part B. Calculate the current flowing through the wire. The current needs the charge, which thankfully we found in the last problem, and the change in time. So again, time, it was given to us as 1 minute, but we know we have to change it to seconds. And then there you go. It's same as the first one. It's plug and chug, pretty simple. There you go. Moving on. So this is the second one. This is a mild problem. The potential difference between a storm cloud and a tree is 8 times 10 to the 6th, that's supposed to be, volts. If the bolt is carrying 1.4 coulombs, if the bolt carrying 1.4 coulombs falls from the cloud to the earth, what is the magnitude of the charge of potential energy of the charge? That's a little confusing. Essentially, what it's asking you for is the work done. So go ahead from the equations that we've given you, try and figure out how to do that out. Put it on pause, and we will go through it right now. All right. So again, the equation you're going to need is work. So voltage times charge. Pretty simple. We gave you you use the equation for voltage, which was work times charge, in order to find the work in this case. So you just rewrite the equation for work. So the equation is, well, the result would be 8 times 10 to the 6th volts times 1.4 coulombs. It gives you 1.12 times 10 to the 7 joules, because work is written in joules. That is what coulombs per volt is. And we continue. Right, and I'm just going to go back real quick. I apologize. The current is in amps. Always in amps. Coulombs on seconds, that is amps. So I just wanted to clear that up. I forgot to mention that earlier. There we go. All right, so the third one is calculate the drift velocity of electrons in a sample of copper, which is 5 millimeters wide and 2 millimeters thick, and also carries a current of 10 milliamps. So for copper, and the free electron density is 6 times 10 to the 28th times meters, negative 3. That's what it is. So the cross-sectional area, so the equations you're going to need are for cross-sectional area and for current. Right there, we didn't give you the cross-sectional area in the first one, so here it is. Your goal is going to be to find drift velocity, and these are the givens. We wanted to write all this out for this one because it's a little bit more complicated. It requires more steps, to be exact, just to figure out the one question. So go ahead, put it on pause, see if you can figure it out, and then we'll show you how to do it. All right, so for the first part, you're going to need to find the cross-sectional area because you can't find the current with the cross-sectional area. So you can't. Sorry, my bad. You can't calculate the drift velocity without the cross-sectional area. So you just have to plug and chug again. Width of the wire 5 millimeters, which is you have to convert it to meters. So 0.005 millimeters. And as well as with the thickness of the wire, same thing, convert it to meters, and you find 5 times 10 to the negative 5 meters squared as the cross-sectional area A. Then you go on to plug that into the drift velocity equation, and all the other givens that were given in the problem. So this gets a little bit complicated confusing down here because of all the multiplication marks. But so the current right here, which is 0.01 amps, because we converted it from milliamps to amps, right? So it was 1 milliamp or 10 milliamps, which is 0.01 amps, times the free electron density of copper, which was given at the beginning of the problem as well, which is right here, times the cross-sectional area right here. Drift velocity, we don't know that yet because that's what we're trying to find, so it's left VD times the charge of one atom. Whew. Oh God, of one electron. Excuse me. Right here. Right, and so we get this. So if you got that, good for you. We're going to go on another drift velocity equation just to make sure that that sunk in. All right, so I'm going to let you read this one, put it on pause, and do the exercise, and we'll be back. All right, again, the goal is drift velocity equation is the same. The givens are obviously going to be different because it's a different exercise. But again, the same kind of procedure. You have to find the cross-sectional area and plug that in. And you get that. 1.6 on 10 to the negative 4th meters per second as drift velocity. All right, so that's the end of our slides. We got all of these exercises on the remediation website, so please go ahead and look at more of those. We hope that we were able to help. I apologize for all my stumbles. And yeah.